Okay, so we have seen how to store data in the array list now. Again, the collections. We saw how to store primitive data also. We saw how to store user-defined data also. And we also learned how to design user-defined data so that it can be stored in array list environment. That's TO, nothing but as TO. All that is okay now. So today we'll go with on new topic. Today we'll go with on new topic. It's called as bulk operations. Bulk operations. Now, what do you mean by bulk operations? Bulk operations means it's something like you have got on collection. Okay, means it can be in any structure. It can be in a tree structure or it can be an array structure, anything like that. So I'll be considering first array structure only. So I want to copy all the values from one array structure to tree structure. Understood? From one structure to another structure. Or I want to check whether, understood? No, I got on some elements in array structure and the same elements I want to copy into what? A linked list structure or a tree structure. So these are the common logics you end up while developing an application. Understood? So these common problems, Java goes on to give you a solution. So always you have to understand concepts here. Okay, first you have to understand concept, and if you want to that concept, no, that concept is already written by them. Where? In some method. That's what is Java telling. Okay, so then it might be like, so you have got some, you want to transfer into some other data structure, or you want to check whether the elements stored in an array, whether the same elements are there in, same elements are present in what? Tree structure or some other structure. They are called as bulk operations. And see an example, you'll start understanding now. So this is our requirement. Right now this is our requirement. So you don't, in other languages you have to code all this. But in Java, you do not bother about coding. All you'll do is what now? Just call a method. More than that, nothing else is there. Understood? So let's see what else, how we do it. So I'll just transfer the values which are there in one array list into another array list. Let's see how you do it now. Okay. So see, array list, list1 is equal to new array list. Okay. List1 dot add, I'll add some values, 10. Then I'll add list1 dot add 20. List1 dot add 30. List1 dot add 40. List1 dot add 50. So there are some values in one array list. Getting it? So now there will be one more array list now. Array list AL2 or list2 is equal to new array list. So list2 dot add, I'll have some values 11. List2 dot add 12. So how many array lists are there now? 2 array lists. So list 1 is containing some values, list 2 is containing some values. If you want to represent this diagrammatically, see this now. Yeah, I'll try it here now. So this is the first array list now. Index starts from 0. What are the values? I've added 5 values. So 10, 20, 30, 40, 50. So this is what? List 1. Now I got list 2 also, which I have created. So what are the values present in list 2? 11 and 12. My requirement is simple. I want to copy values from this array list into this array list. How will you do now? Understood? So you don't have to write logic in Java. That's the requirement. So that's the concept. You can take it as a concept or that's the requirement. Okay. Now to do this functionality, I want to add the elements of what? List 1 into list 2. You understand now? The list 1 elements I want to add it into list 2. That is bulk. I'm showing you 5 data. Now what if there are 1000 records? Think big scale. Here we are learning with small data. Okay, but later on it will become big. So just all I have to do is, see this, list2 dot add all. There is a method called as add all. That's it. List2 dot add all of what? List 1. Finished, over. Understood? So all the elements will be copied now. How many elements, sir? 10, 20, 30, 40, 50. And doesn't mean that it grows now. Understood? So again, if I want, I can continue adding other elements. So list2 dot add 33. list2 dot add 44. I can add more values. I can add, and notice I'm adding the numerics in the form of string. Understood? I'm adding it in the form of string. So then next, what is that value I've added? 33 and 44. Again it can grow. That's what I'm trying to say. But you copied the values from one list into other list. That easy it is. Okay. Not only that. See, you copied from one list into other list. But next, I want to copy the elements of linked list into array list. Array list into linked list. Fine. Very simple. See here. Linked list. List3 is equal to new linked list. You can, if you want to add some elements, list3 dot add of what? 11. List3 dot add of 22. So now see. So here when you do this, one linked list gets created with what? Pre, next and all that node. So what are the initial values in this list3? But it is linked list now this time. Okay. And what are the values I have added? 11 and 22. Just you say list3 dot add all of what? List1 finished. Now same it will be copied now. Which one? What are the elements? What is the first element? 10. Is all these elements will be copied into what now? Linked list. 10. Then what? Pre-next will be there. I am not writing it. But just understand, 10, 20, 30, all will be added here. Whatever you have got in list 1 will be added into what? List 2. Imagine, from one structure you can copy into another structure. What a brilliant logic it is. But they already written it for you. Okay, so that simple it is. Understood? So like this we can do bulk operations. Not only that, you want to check, see this is about inserting and values from one collection into another collection or from one structure into another collection. Apart from that, sometimes you want to do some other operations like you want to check whether the elements present in list 1 is present in list 2. Like that scenarios will come. You'll be having two lists. Now whether the elements present in one list is present in other list. That also fine. There's one method. What? Contains all. There's one method. I'll be showing you those methods. Then next, there's one more method. Like if you say remove all. Remove all is there. So I'm doing nothing today. I'm just exploring more methods now in the library. So today we are going to see what? Some more methods. So we have some programming problem here. Okay, or we need, there is some concept. Okay, and these methods are implementing that concept. First you have to understand concepts here. When you are working with data structures now, what are the different problems which arise? And all those problems has been implemented now. So one side is concept. More concepts you know, then you'll know how to use the library. But problem is people directly try to by heart the library, which is not possible. So until and unless you understand the concept here, there is no point in learning the methods. Understood? So more concepts you know, the more better methods you can understand here. So I'll clear it for you. You got this idea now? So I'll show you some more methods now. So that is what you mean by bulk operations. That's the topic. We'll see some more methods, but very simple. And notice this add all method. Okay, these are all methods present in what? They are methods present in for every structure. Definitely it will be in what now? Collection interface. See, this is something like from one linked list you want to copy into array list. From one tree set you want to copy into what? Array structure. So from anywhere to anywhere you want to copy. So from one collection you want to copy into some other collection. So that is why they are giving you this support. So it is needed in every structure. So that's why they'll keep it in the top. Which one? Super interface called as collection. So you're exploring more methods now. So what I'll do, I'll just show you some examples which will give you more clarity on the subject now. It's very simple now. See, I've just renamed my project to, because you got more examples in ArrayList. I renamed the project to 2A ArrayList examples. Till now what you coded. And I've got more. So I'll be going to be some other examples too. Means they are all related with what? ArrayList only. Understood? So that's the form, what is that format I'm using to give you the examples. Yes, see this now, array list. So there's one package I have created, bulk operation. I'm neatly organizing so that you can refer to any example whenever you want. com.cluster. See, till now I work with this package, com.cluster. Understand how I organized. Any example you want, in one shot you should get it. Understood? Because we are going to see plenty of examples. It's not like other institute where they teach you one example and say array list is over. We have to work too much on array list and there will be plenty of examples now. So organize data properly. Okay, organize your examples properly. Understood? So then next, today I'll be going with bulk operation. Yeah, the same scenario now. Just see this. I'll start adding now. See, there is an array list. I want to add these values into what? Another array list. Finished. So simple. So what did I do? There is one list 1. Those values I want to put it into list 2. List 2 is already having 2 values. I added the list 1 and again I can continue adding. It keeps growing. Understood? So then I'll print values in new array list 2. So that's it, over. See, 11, 22 are the first values what I added. Then these are the values of what? List 1. Then 2 more values I added, 33 and 44. Yes, it's holding it. But I copied the values from one list into another list now. Getting it now? So this is how it happens. Okay, next. Now we'll comment this. Okay, what is the difference between add and add all and clone? Add all and clone. Clone, it will create one duplicate copy with same values. But here in add all, what happens? It will create one more new one only, but it will be adding. A clone means same ditto duplicate copies will be there. What is there in list 1 will be there in list 2. But in add all, what will happen? You can have extra values. Original means whatever is there in list 2 will be there plus the values of list 1. Understood? So you should know now what you want. Your requirement you tell. Depending on that you have to call the method. Then next, this is done. Say I want to put the values into linked list. Fine, that's all. Create an object of linked list. Now that is list 1. Those values I want to put in what? Linked list. Just now I showed you. So fine, it will be added. Just I am saying what? List 3 dot add all. See, these are the elements in array list. So the same elements have been added into what? Linked list. Internally the structure is different, but you are not bothered about that. You don't implement anything here. So it will be using linked list structure and storing all the values. So it will copy the values from that place will be copied into this place now. Understood? Then next, I want to copy the values from array structure into tree structure. Fine. I got a tree set 11, 22. Then what? I am adding the values of list 1. But be careful here. The values will be stored in sorted order, not in the same order. See, first is 10, 11. Fine. See it. I added the tree list here. But what was the first element? In tree set I added 11. You added the list 1 here. So when the tree set is growing, getting created, first value is 10. 10 is coming from where? List 1. Then 11. Then it goes on. In a sorted order, it will store. Anyway, I am not explaining the tree structure. We will be seeing it. But just understand the values from the array structure got copied into tree structure. So such brilliant it is. Understood now? So fine. And again, you should not by heart, okay, add all will copy all the values. You have to refer to the document and study. You understood all the concept. But again, always it's advisable to refer to the document now. See this. Array list. Anything you can type. Go to the documents. You see this now. These are the methods we are trying to learn. Add all. Okay. So this is the method what I thought you know. But what it says, you have to pass an argument of type what? Collection. Leave this syntax. But you have to pass an argument of type collection. But what is basically collection? An interface. So can I pass an interface as an argument? You know how to pass an interface as an argument, no? What will you do? You cannot pass an interface as an argument. Instead, you can pass a class implementing the interface as an argument. That's what I have covered. Okay, passing interface as argument and all that. So fine, that is the syntax now. So now, if it is collection, I can pass any implementation. No? That's what I was doing. In add all, what did I pass? I passed linked list. I passed. I was passing everywhere a list only. Array list only I passed. See this. List is a subclass implementation of what? Collection. List 1 means list 1 is of type array list. But array list is what? Implementation of collection. Understood? See, here I showed you copying elements from array list into other structures. Similarly, you can copy values from other structure into array list also. Vice versa also you can do. But I am concentrating more on what? Array list. My topic is array list. See, supposing I am having some values in linked list. Linked list LL is equal to new linked list. I will fill some values. LL dot add. There are some values. 10, 20 I will add. Then I want to copy this into array list. Fine. Array list AL is equal to new array list AL dot add all. Finished now. From linked list I copied into what? Array list. That is the meaning of that. Add all method accepts an argument of type what? Collection. So it can be, you can send any collection into it. It can be either array list, linked list or anything like that. Understood? So that's how you have to understand the library. Collection. Understood? So then next, after that, let's see one more example. Are you clear this example? So your topic is, don't forget, bulk operations. You want to transfer data from one structure into another structure or another collection, anything like that. More examples we'll see. And look at the names I have given clearly. Go in the order itself. 1, 2, 3, 4 only you go. Don't jumble up. Wherever you want to, don't go. Now in the second one, see this. There is add all method. See here, already one list is there. Second list is also there. But I want to add the first list into the starting from second index. Fine. One more method, man. Add all. You can see that in the document. What does the document tell? This add method we saw. Now we are seeing this add all method. Okay. So one, I think, these two add methods you have seen. These two add methods you have seen. One only adding the element. Second one is adding at the specified index. I completed this add all method now. Next I am showing you this add all method. Specify the index and the collection. That's it. Over. So don't by heart anything. Literally you don't have to by heart here. Okay, see here. So already on which one is there now? Second list is there. In the second list, what are the elements? What are the elements? 11, 22. Already it has been created. The second list is already ready here. With what values? 11, 22, 33, 44. So it's already ready with 4 elements. Now what did I do? List 2 dot add all. In the second index, add the elements of list 1. Fine. So all this will be moved this side now. They'll shift. Understood? And in between what will come and sit? 10, 20, 30, 40, 50, 33, 44. Like this it will sit. It grows. That's simple, man. Imagine you are not even writing a logic for anything here. Understood? So anyway, we are just seeing one more method now. Output. So initially what was it having? The second list. Like this. After adding what? Values in second array list after adding first list. See there? How I wrote? Same way it is in 11, 22, 10, 20, 30, 40, 50, 33, 44. That's it. So working with data structures in Java is what? Like eating cake. That easy it is. You like pastries, huh? Eat. Such easy it is. Understood? So that easy they are made working with data structures in Java. Clear? The next example. Yeah, see this. There are 2 lists now. This is list 1. This is list 2. See, they will be get created dynamically. Understood? They will just get created dynamically. Here I am hard coding. Now I want to check whether the values in list 1 are there in list. I want to check. Understood? So what will I do? Just I'll call a method called as contains all. Finished. Now contains all is a method present in what? Collection interface. Same. Refer to document. See, I'm covering all the methods now one by one. Understood? So then contains, this we have already checked. It is used to check whether it contains that particular element or not. But now we are checking with contains all. It is not here. Huh? Okay, and then this method will be where now? If it is not here, it is not there in collection means where will it be? Huh? Oh, we are checking in array list. Huh? 1 second. It should be there now. Okay, it is there in collection interface. Sometimes they will not be having it displaying it there, but you can check in collection interface. You can see the method is there called as contains all. So you can check it like this. Returns true if this collection contains all the elements. Remember, even if one element is missing, it will give what? False. Return type of this method is boolean. So it will check ditto ditto. All elements of list 1 should be present in what? List 2. See. That's simple. We are not writing any logic only here. See here, this is the value of first list, this is the value of second list. Now all the values of first list are present where? In the second list. See the same values, and I didn't do add all. Simply that I created separately, this I created separately. See here how I have created the two lists. This list is separate, this list is separate now. I didn't do add all, nothing I did. They are two independent lists. Okay, then I am checking. How did I check? List 1 dot contains of list 1. Okay, so it is true. What is the answer you got here? True. I'll just remove one element here. See in the list 2, I'll remove 20. Now you check. It will be false. It has to contain all the elements of list 1. What is that? False. Getting it now? Done. Then next. Now whatever values are there in list 1 should be removed in list 2. Fine. What values are present in list 1 should be removed in what? The list 2. You don't, it's not rocket science here. What did I do? List 2 dot remove all. Understood? So when I say remove all and pass the argument of list 1, what will happen? All the elements of list 1 will be removed in what? List 2. That's simple. So this time you see the second list now. What is see, this is first list, this is second list. Now I am printing again after removing the elements. Can you see the 10, 20, 30, 40, 50 anywhere? No. Initially it was having the values. See, these many values have been eliminated. Yes or no? These values have been eliminated, and only these values are present in what? Second list. Getting it? Understood? Now remove all. So this means values in second list after removing it. Okay, fine. Next. Now can you guess what will this do? Retain all. It will retain the elements of first list, but remove the elements of current. Means see, it might have it is having means in list 2 you will have only elements of what now? First list. Remove all was removing it. Retain all will retain it. That's the difference. Remove all was removing all the elements of first list, but retain all will retain the elements of first list. See, in second list now, even though there are so many elements, you will be having what? Only values of first list. See there. That's simple.
It's like control Z.
Huh?
Undo.
This is undo. Okay, so it is retaining the values. Understood? So, are you clear with this? Are you clear? So, it's something like add all, retain all. Okay. So, then these are the methods. Work with that. So, now see in Java, okay, this is one thing. Then next, we'll see some more operations. Yeah, not only checking only in ArrayList and ArrayList. Now I'll check, I got a linked list here. Same operations I'm doing. Now some elements are there in ArrayList, some elements are there in linked list. I want to check whether the elements present in ArrayList is present in linked list now. Understood? Fine. The same method I'm calling, nothing more. See this. Don't think only two ArrayLists can be checked like that. Even you can compare what? One structure with other structure. Reason is what? This contains all, retain all method is present in all the classes, all the implementing classes. Fine, see this. So these are the values of ArrayList. These are the values of what? Linked list. And linked list contains all values of ArrayList. True. Understood? Remove all. In linked list, whatever elements are present in that array list now, they will be removed. But actually they are present in what? You are following now what's happening now. Okay, so there are two lists, man. One is list 1. Okay, here removing this, it will remove all this. But this is in linked list. So earlier, means in the previous example, there are two array lists. Okay, it was removing means it was removing like this. Okay, now but we are storing it in what? A linked list. So whatever elements are present in array list will be removed in linked list, because I am telling list 2 dot remove. In list 2 I am removing all the elements of first list. Simple. See, working with data structures is so simple in Java. Unimaginable it is. Clear? So it is doing it. Then next removing it. Retaining also you can do. Same. You understanding what is retaining? Only the the elements of array list will be retained in linked list now. So you think about massive data now. Don't see 5 elements. Okay, that's how it works in Java. So this is what you mean by bulk operations. So how many methods you learned now today? Here, 4. It's all about methods. Contains all, retain all, remove all. Understood? Add all. That's the meaning of those methods. Clear? Okay. So that ends bulk operations. Nothing more with bulk operations. Very simple concept. But for us it is very simple. Imagine the same things you want to do in what? Some other language, do it. In C language I'll give the task. Okay, prepare on linked list. Means you have to prepare on linked list. Fill values into that. Then again if you want to copy those elements into tree structure, again you have to prepare one tree structure. Then copy elements from here to here. So half of the time or half of your life you are wasting in what? Writing such unwanted logic only. But it is not unwanted. Every project you will need this. So since this common logic is required in every project, what will Java do? Give it in the library. Understood? So this is how they have designed it. Are you clear with all this now? Okay, fine. See, now just let me make you understand a little bit of Java. Okay. See, Java is a very simple language. People don't follow Java properly. Okay, the fact where the first major problem for people who are learning Java comes where, you know, they are unable to understand what are the different data types. That is where the first problem comes. Okay, if you tell anybody you don't know what a class is, they'll tell what? They'll laugh at you ulta. Understood? If you tell them, if I tell them you don't know what is a subclass, what will they tell? They'll tell what? I know what is subclass. I know what is abstract class. I know what is interface. The whole subject of Java stands on this only. Whole subject. Okay, and these data types are very powerful and they can implement oops. You know the story of all this. We have extensively studied completely these topics. That much vital information is required. Only then you can enter the library. Okay, so first see what did Java do? Java gave you this full support and they said they asked you to write the logic. First they gave you these data types and they said you write the logic. Then they realized some common things are written redundantly in what? All applications, all programs. Then they thought, why should the developers write? Instead, we will only write the code and give it to you. So one option is, see, they have given all these things for you, data types. Whatever logic you want to write, you can use this and write. But Java says what? You don't write. Just use it. So that's what they do. They will prepare all the logic, and while preparing their logic, what they'll do? They'll be using these data types. Depends. Okay, see here, that is when you should be very clear. So you should now have a clear idea why a class is used. why a subclass is used, why an abstract class is used, why an interface is used. Okay, this is pure core Java now. If you're good in core Java, then only you can understand the library here. Understood? Otherwise, it's practically impossible for you to understand library, because we're going to see more here. Okay, so once they implement this logic, you know now classes are used for doing what? Concrete implementations. Subclasses are used for doing what? Adding or changing implementations. Abstract class is used for doing what? Partial implementation. Interface is used for doing what? No implementation or setting standards. This is the actual scenario here. But if you tell anybody you don't know what a class is, they'll tell their own style of definition. What definition I told you right now is the actual definition of class, subclass, abstract class and interface. But if you ask anybody what is a class, what they tell? They have one by-hearted style. What? Class is used for doing encapsulation, it will hold the data, all that is correct. What is class is correct. But why is the class used? Why do you use the class? When do you use the class? That is the question. Understood? You always have the answer for what? What is a class? What is an abstract class? That you have. But you do not have the answer for when to use the class. What then? Why to use the class? How to use the class? Means how to design the class. Understood? So these answers you don't have. You always have the answer for what? What? One answer you are having. That is the reason you fail to understand Java. Understood? So now see, what is a class? Yes, your answer is correct. Whatever you know, because in college you have by-hearted a lot on that. That is correct. When to use a class? When you want to do a concrete implementation. Why do you use a class? The same. When you want to do concrete implementation. Okay. How to use a class? Yes, you should know now. Class will be designed like it will have a class name, then constructor, methods. You should know argument, return type. That's how you design a class. Then finally, if you design all this, what is the advantage now? What is the advantage of designing a class? Reusability. Simple. Means you write and you can reuse it. But here they know that if I write, we know what classes we write. We can't write any logic only. So that's why what Java people tell, you don't write any logic only. You be safe. We just use our logic what we have provided. Understood? So this is their actual message to the Java developers. Unfortunately, this message nobody is understanding clearly. So programming, see, what revolution Java has done is, initially people were coding in binary. Like what? 1010. This was the style of coding. Later on high level languages came. What is high level language? C and all that. In C at least something is understandable. For int means something like that. It's high level language. Java has made programming into something like English. No, forget high level now. It's more like English. You're seeing now. Add all, contains all means what? It's pure English now. So actually to learn Java, what you need? You should know English. Prerequisite knowledge for learning Java is not C, C++. Prerequisite knowledge for learning Java is what? English. If you look at the code, like open, clearly you can see the method names. They are in English. That simplified programming language it is today. It's almost all means developers were long back dreaming. What is this 1010 coding? Why can't we code in something like English? Here it is something like English only. Understood? But it's a method name. That's it. You call that method name, automatically that method gets executed. So this is how the language has been designed. That brilliant it is. How many ever words you use to express this language is less only. Unfortunately, people are not understanding the subject. Okay, they end up by hearting everything. Okay, I call this method, this will happen. I call this method, this will not this will happen. Ulta you have to learn. I want to write some logic for a concept. The scenario is I want to write a logic for some concept. Java says don't write. It is there in a method. Search. That is the difference between other languages and Java language. So the problem is you don't know more concepts. Because you always see when you come out of the college you have a josh of what? Writing logics. What if I ask you anything? I want to write logic. I want to write logic. But tell me what logic you want to write. You want to write logics, I agree. But what logic you want to write? That is there, already implemented. In other languages you have to write. That is the difference between Java language and other languages. And here the key is, the thing is, this is how the design of Java is like this. Understood? So here, until and unless you know the proper data types, you can't end up in using the library. That's one thing. Until and unless you understand the which one, these four things properly, you can't end up using the library. It becomes very difficult for you. And see here what they have done. In Java it's all about, I'm telling you last thing. Okay, just clearly understand this. In Java, developers do not write any logic. While teaching you this Java, did I any day teach you writing any logic? I didn't teach you. You go and refer back to all the notes and programs or whatever it is. Okay, there I consistently went on teaching you how to design these data types, how to write methods inside them, and how to set the arguments, parameter, return type. So whole of Java programming stands on only one subject: creating objects, sending arguments, parameters, return type. That's it. This is Java. Understood? So in Java, for coding Java now, see I wrote so much of logic now. Means I didn't write, we went on calling methods. For calling methods, okay, you tell me, means you know how to call a function, no? Calling method is nothing but what? Calling a function. But Java has its own terminology. Now you understand, to call a function, now I'll put the questions to you. Should you be a computer science engineer? Now you answer now. To call a function, should you be a computer science engineer? No. Means anybody can learn Java. Yes or no? Why to call a function I should be from computer science? Huh? I can be from any stream, no? Yes. Should you be computer science? No. Should I have 90%? Even if you are having 30% or even if you are having 90%, end of the day what are you doing here? Calling one function. Now unfortunately people don't understand how to call a function here, because they don't know how to send the proper arguments. They don't know how to accept the return type. Now who has to be blamed here? Your basics, which you neglect so much. All the first 40 videos is based on that only. Unfortunately you don't realize that. And now you start understanding the importance of all the previous classes. Understood? So just go and refer if you are having any doubts in what? Calling methods, arguments. Clearly you start understanding. I've shown you everything there. How to send a class as an argument, how to send a subclass as an argument, how to send an abstract class as an argument, how to send an interface as an argument, how to have the same all the 4 data types as return type, arguments, parameters, all I've taught you clearly. So I was only focusing on what? Arguments, parameters, return type. Nothing else I focused while teaching you Java. And I more went on giving you information on how to design a class, subclass, abstract class, interface, and when to use which one. That is what I was explaining you. And now you can clearly get the message of it. Why I was stressing so much on those particular topic. So because it's our experience now. And this Java can be taught only by a person who has got tremendous experience. Understood? You cannot learn Java on your own also. You cannot learn Java by any fresher also. Here tremendous experience is required, because we know how they have designed the language. We know how they have invented the libraries. And after inventing the libraries, they organize it. How they organize? Classes they'll write. First they write logics. Logics they'll write in methods. Methods they'll keep in class. Class they'll keep in packages. Neatly organized. Whatever you want to use, import. Create object. Creating object is nothing but what? Bringing their code into existence. Call the method. Finished. Over. Now how do you say Java is difficult? You answer me this question now. Quite simple. Unfortunately people are not understanding. And their problem is in this basics. What? Class, subclass, abstract class, and interface. And opening the library and showing it to you how they have designed it. Understood? So Java is fully open source. You want the source code of that, it is visible. You can extract it and see it. You want the documentation for it, it is visible. In spite of having everything like a mirror here, people are unable to use this library. And with powerful editors. So one thing what I will tell you, do not worry about writing any logic. First you tell what logic you want. Then you can see Java gives you in its library. Till now you are thinking, I want to write logic, I want to write logic. Do not worry about writing logic. So Java is made that easy for programming. Understood? It's one of the most easiest language which any developer can learn. Anybody can learn. Understood? And why they got this brilliant library is one reason. Because it is platform independent. No other language can dare give this kind of a library. Okay. Once Java gives you this library, other languages will follow suit. Like follow means they will follow Java. Java finishes some library now. Same thing. Microsoft will come now. In what? C#. They'll release the library. Almost all same, ditto to ditto, no difference. So you should know the concept. If you know the concept, you can survive in any language here. Understood? Learning a language is very easy today because all are high level. You should know only how to use the library. In all languages, you end up only using what? Library. But it depends on how powerful their library is now. Understood? So Java is giving you immense support for developing any type of an application. See, when you're developing applications, you'll come across scenario. There are too many programming problems you'll get. Hardly you have noticed anything. Okay. But as you develop the applications, you'll come to know there are a lot of problems you'll face. And Java goes on to give you what? Brilliant solutions for all your problem. Full in the library. Understood? And that is what we are exploring now. This is actual Java. Understood? This is actual Java, not till now what you learnt. The actual Java starts right now of using the library. Understood? So be strong in what? Your basics. Don't neglect them. Okay, now coming back to our data structures. Understood now the library, everything? Any questions? So in Java you should not get any doubt. Why you will not get any doubt? You should not get only. Reason is what? It is a mirror. You want to do something, first what you want to do, answer that question. You get that question properly. Once you get the question, Java gives you the answer for that. It's all about doing R&D. Call that method, see what happens. Purely doing R&D here. Understood? So literally your questions will come to zero now. Understood? Every answer you got here. Okay, and it's by practice you will get this idea here. Okay, any doubts you have, it's purely through practice. You try code, you'll get the output, you'll understand what's happening. Again code, again call the methods. Here we are not writing any logic. One thing is very clear. If you write logic, then you can come and question how to do this, how to do that. Understood? So even when you go to interview, what happens? Same things are asked. Yes or no? Now what will you tell? You have to tell the name of the method now. More than that, what are you telling in the interview? Okay, so Java's means your pay package. Pay package, yes, is directly proportional to what? Number of packages you know in Java now. So directly proportional it is. Okay, you want 5 lakhs, more packages. Means experience now. You want 10 lakhs, more packages. 25 lakhs, more packages. Understood? So it's all about your patience. How good you wait and learn all these classes in different packages. You understand now, pay package is directly proportional to what? Java package. Now why do I say this? In Java package you got library. That's the library. It's clearly justified. And you struggle for job. So in the industry also when you enter, no, you should know which one to use when. But you rush up. You rush up in telling what? I know everything, you'll enter there, and there you fail to code. Because you don't know how they have designed it only. So there is no use in rushing through anything here. Understood? All you have to do is learn it with patience. Like this, clearly how to use the library you have to learn. Understood? This kind of a guidance I have given you. So see, no trainer will guide you like this. This is openly I am telling you. They only go on with by-hearted style. Okay, but here, because of my experience, I am teaching you Java like this. I am clearly telling you, to learn Java, actually, only guidance is required. Understood? I am giving you guidance to learn Java. Understood? You people think we train Java in depth. I am telling you, this is the basics, which unfortunately other institutes don't train you. Get this point very clear. Simply they will finish ArrayList in one day. All means one day ArrayList, one day tree set, over. This much of operations they will not teach you anywhere. Understood? So getting the clear idea about this. So you should not get any doubts from now. Go practicing the library, refer to the documents, read books, refer to more documents you got. You type in Google examples for Java means what? ArrayList. And one thing I'll tell you, what examples I have given you, nobody can give you. That is openly I'm telling you. It's with experience I'm delivering. Understood? So that is one thing. Any example also you take. I'm not taking it from any book. We are coming with what? Experience here. Understood? So practice more. So you should know how to get your solutions now. Because in industry you are on your own. Nobody will be coming there to help you. If they give you a task, you have to do it now. Understood? So you should come to the level of delivering things now, instead of depending on me and anybody. So that should be your ability from now. Understood? Is it clear to you? So it's all about packages. Learn more package. So okay, we'll return back to our topic of what? Data structures. Bulk operations done now. I just showed you now. So keeping this in mind, you learn Java now. Don't by heart anything. Yeah, we'll come back to data structures. Yes. Now, what is a data structure? You got a clear idea now. It's all about what? Holding data in primary memory now. It's all about holding data in primary memory. Yes, good. Okay. So once you hold the data in primary memory, you have got different structures. This is your application now. Values can come from UI or they can come from database, irrespective. So once you retrieve it, you got plenty of structures here. You can use any structure depending on your requirement. Okay. So data structure will hold value. So first thing what the data structure does is, you use a data structure. See, with data structures, we do only few things. It's not a major subject at all. Only people are scared about it. But you can't ignore it also. If you ignore it, you can't write the logic only here. Understood? It is mandatory. But Java's benefit is, it is there in the library. Understood? So in data structures, what we do is, let it be any structure. Let it be any structure in the world. First thing what you're going to do is what? 4 operations. What are the 4 operations you will do? Inserting, updating, deleting, and reading. It's nothing but called as what? CRUD operations. But it is related with primary memory. C means create, R means read, U means update, D means delete. Creating a record, reading a record, updating a record, deleting a record. But all is dealing with primary memory. That's one thing. You will know about this now. So means anyway, to learn that, we are using one structure now which is called as array structure. You understand it in one structure, you can understand in any structure very easily. That easy it's going to be. Understood? Only one structure you have to focus. So work hard on one structure, at least array, which is extensively used. Understood? So next, apart from that, with all data structures, what do you do the next thing? You access the element, accessing the element one by one. Accessing the element, or it's also called as what? Traversing. Traversing we say, means visiting the elements one by one. The third thing what you do is sorting. If you know these 3 things with data structure, it's over. Nothing else is there in data structure. Understood? It's not a big subject also. That simple it is. Okay. And we'll see how Java goes on to give the support for the other 2 now. We have completed this, yes or no? So see, in any structure you take, this is common. You take array structure, same old story. Linked list structure, same old story. Tree structure, same old story. It's not going to differ. Any structure let it be. Yeah? So this is going to be the same in all structures. You understand this concept. I'm telling you concept in one structure. Definitely concept is same. Only the data structure will vary there. Understood? It's all about doing what? Inserting a record in some other structure, or sorting in some other structure, or visiting the elements in some other structure. Till now we have completed the first one in what? Array list. So we are pending with what? Accessing the elements, sorting. I'll cover it. That's all about array structure, nothing more. Understood? So today I'll be going with what? Accessing the elements or traversing. Then I'll go with sorting. Yeah? So tomorrow I'll be saying sorting. Actually traversing only will take time. So are you clear with all this now? So get concepts now. Here in Java, sorry, in cluster we are teaching you concepts, not Java. Okay. And to learn Java, one thing is clear now. To learn Java, common sense is required, not percentage and branch. Because just to call a function, you need what? Common sense. Which function to call? What are the arguments you have to pass? What is the return type to accept? So Java requires common sense for coding, not computer science branch, not what? Percentage. I am 60%, can I learn Java? I am 20%, can I learn Java? Failed. 20% means. I am 150%, can I learn Java? Means 5 attempts. Understood? So for learning Java, your percentage is not required. Your branch is not required. Just common sense is required to call the methods. Clear now? Okay. So anybody of your friends ask, tell them this first story. I know Java, I know Java. Okay. So we'll continue. Yes. So I got some array list. Array list. List is equal to new array list. list dot add, I'll add the elements C, A, E, P, D, E, B, F. You know how to add now? Call the add method and all the values. Like this I added C, A, E, B, D. Okay. So means your array list can contain what? Duplicates. It will store this elements in the same order as inserted. Okay. All that you know now. Understood? So fine. You got now. So SOP list means what? It will print all the elements now. VI should not, printing is secondary now. If you want to process the data now, one by one you should access the data. See, you can get the data. How will you get? You know, like if you, this is printing. See this now. See the problem. List dot get. I can get only the value in the third index. But I want to get the values in all the indexes. So can you go on writing list dot get 1, list dot get 2, list dot get 3? You can't write because you'll never know the size of it now. So better is what? Visit the elements, visit all the elements now. Your requirement is now you want to visit all the elements. So technically if you say, let me count now. How many elements are there? Okay. So the first element is there called as C. Then you got A, E, B, T, E, B, F. Clear? These are the elements. So my list is there now. This is my list object. Fine. So SOP list means it will print. I am not interested in printing, I want to process now. So you have to get now. So this is a bad approach now because you never know the size now. So you have to visit one by one now. So how will you visit now? How will you visit? How will you visit? You will use the for loop. Yes, see this. You can do it like this. For int I is equal to, or I'll just write it here. Clearly, I'll remove it. For int I is equal to 0, I less than what? List dot size I plus plus. Yes, here I'll print, but you're accessing one by one now. Yes, so okay, you can get it here. I'll get it. List dot get of I. Return type is what? Object. Remember that. I'm passing I here. That you have to typecast. How do you typecast? You can say e dot to string. If it is string type, you can do typecasting like this. Yes, you got the first element now. Do whatever you want. I am printing now. That simple it is. But again, Java says you don't write all this old logic. Okay, they are giving you some library support for visiting the elements. So that is what we'll see now, called as iterator and list iterator. So the topic is what now? Visiting the elements. Or accessing the elements. I'll show you how to do it. So this is our actual requirement. So Java gives you, see, for all your problems, Java goes on to give you what? Solution. See, the thing is accessing the elements of a collection or traversing. If you want to do it, you can do it, you'll get the output. I'm not telling now, but Java insists to use its library support. Let's see how you do it. See, collection framework provides 3 interfaces. It provides you 3 interfaces to visit the elements of a collection. I'll just remove this for you. Okay, which are there? Enumeration, iterator, list iterator. So I'm going to introduce what now? 3 more interfaces today. Understood? So anyway, enumeration, iterator, list iterator. Now enumeration is a legacy class. It's old. It was there in 1.0. Okay, and it was introduced in 1.0, and it can be used with only legacy classes. Which are the legacy classes? Vector, stack, hash table, properties, dictionary. So you can use it with only 5 classes, remember that, because it's legacy. Okay, there are some problems with this. That is why they invented one more interface or introduced one more interface called as Iterator. So it was added in the framework. You know, when was the framework added? Collection framework 1.2. So it was added that time, and it can be used to visit. Means it can be used with any class. In ArrayList also you can use it. Okay, tree set also you can use it. Hash set also you can use. Anywhere you can use it. Iterator. List iterator is also there. It can also be used for iteration. Okay, or visiting the elements. But this interface can be used with only classes implementing the list interface. So there are some differences between enumeration iterator and list iterator. So to discuss the difference, first you should know it. Then only I can tell the difference. Okay. So first we'll study one interface called as iterator. Then we'll say list iterator. Then we can understand the differences between iterator, list iterator, and then enumeration. So until and unless you study it, there's no point in discussing the differences. Okay, so to visit the elements, we are not going to use the for loop. We are going to use what now? These interfaces. Clear? So it's very simple now. Are you clear with this? So 3 are there. I'm going to show you the first one now. Which one? Iterator. So anyway, just add the elements. Assume that I've added. I cleared it here, but you add all the elements. Understood now? I've drawn it there. So after adding, just call on method. That's it. The return type is an interface. Now this is pure common sense now. You call this method, what happens? Return type is an interface. That's it. In Java, what is programming about now? Calling method, accepting, return type, continue coding. That's it. Understood? Returns an interface. Next. See, once you get this, you have got an object now, and it is pointing to ITR. Okay, it's like a cursor. It's like a cursor, and it is pointing to the before first element. It is pointing to before first element. See, the index is 0. Total elements are 8. Index starts from 0. It is pointing to before first. Means before the 0th index it is present. We don't say before 0th index. Instead we end up saying before the first element. Understood? So it is present. So it is pointing there now. So now I have to visit the element. So I will tell while itr dot has next. So this is, see, iterator is a method in which interface now? In which class? It is there in which one? Collection interface, because it can be used with any class. So one more extra method you are saying of what now? Till now we have studied 4 methods. Contains all, retains all, remove all. Now one more method you are saying now. Which one? Iterator. Like that you study. Don't by heart. Understood? One by one we are seeing all the methods now. Okay. So iterator, I find return type of that is that. Now again in iterator we'll have more methods now. One of the method in iterator is has next. So the return type of has next is boolean. It checks whether an element is present or not. That's all. But the cursor is not moving. It only checks whether the element is there or not. So has next means what? Element is there. Right now it is there. So I'll put it in the while loop. So then I want to visit the element. See, one thing is like this you take now. Okay. Boolean B, one second. Boolean B is equal to itr dot has next means return type will be true. That's all. What will you do with the true value? Okay, I want to visit all the elements. So you can check if you want. It will be true because the element is present. If the element was not there, it would have been false. Okay, fine. Now see this. While itr dot has next. So it will be true now because an element is there. Fine. It will enter the loop. But after entering the loop, what I need? I need the element. So what will I say? Itr dot next. So next is one more method in the iterator interface. Return type of itr dot next is object. So that I will typecast to what? String. Typecast it to string and use it. Finished. You are using now. That's it. No for loop, git loop now. Why means we'll check. It's better to use iterator over for loop. Okay, why? I'll give the answer, but just learn how to visit the elements. Yeah? Obviously you can do it with what? For loop. But this is much better. Yeah? Why you will understand. So that's it. So what happens now? See how it works. First element. Now the cursor. See here it is only checking. ITR dot next means cursor will move now. Cursor will move from where? Before first zeroth element. Or first element means zeroth index. And you are getting the value printing. If you don't want to print, use it. I am printing here. Just showing you why I am printing, to show that I have got the value. Understood? So later on we will process it. Then again loop will continue. Has next. Where is the cursor right now? In the zeroth index. So it checks. Is there an element? Yes. But it is not moving. Understood? While true, it will enter the loop. ITR dot next. Now it will go to the next element. And it will give you. So has next only checks whether there is an element or not. Next actually gives you the value. Understood? So it is done. So I'll get it. Then what will happen? Okay, again it checks. Has next. It goes on now, iteration. Okay, has next. It will give that again. Next, it gives you the element. Use it. Again the loop continues. Has next. True. ITR dot next. See, has next is not moving the cursor. Next will move. If you want, I'll repeat it again. See this. I got the cursor. Yes. Has next. It only checks whether the element is there or not. If true, ITR is here now. Where is the cursor? Here. Okay. ITR dot next means from now, from there it will move here. You are getting the value. After getting it, what will happen? You can use it. After using it, means the while loop completes. Again it starts iteration. Has next. So again it checks there is an element. Still it is not moving. It enters the loop. Then what? Next. Now it moves. You can use it. Then again has next. Checks whether there is an element or not. True. So then what happens? Enters the loop. Next. Now it will visit. Like this it goes on till the end and finishes. One by one it will give you the element. Understood? This is how the iterator works. Okay. This is the library support now. What you are seeing is the library support. Okay. Are you clear with this now? Okay. Very simple. See this now. See this, these are the elements what I have added. Shall I clear what I have written? You understood the logic now? Yeah, see this, there are some elements. So if you add it like this, that's how it will be stored. Understood? What I have written here, that's how it will be stored. If I print SOP, what will happen? It will print just the values, nothing more than that. So it will print like this. Who is interested in printing? Storing is fine. I want to access it one by one now. One index, one value you can get. How will you get? Get, you can get. Another value, get, you can get. But I want to visit all now. So that is when I'll comment this SOP now. See this. What I'll do, I can use the for loop also. There's no issue with that. For int I is equal to 0, I less than list dot size. Correct? Okay. See this output. Then we'll see how to use the iterator. Yes, one by one I'm accessing now. Yes or no? Okay. Then next, we should not use for loop, I said. Instead we go with what? Iterator. Yes, now see this. Simple. List dot iterator has next. Done. Done. Okay, second visit. Now we'll come to the interface. Which interface? Iterator interface. Learn with document. Learn with document. Don't learn without document. Yeah, if I call the iterator method, where is this method now? Iterator. It is available for all classes because it's in collection. So the return type of iterator is what? Iterate method. Iterator is the method. Return type of that is iterator interface. Method name, interface name. Don't get confused. So it is interface now. So once you go there, how many methods are there in this interface? 3 methods. That's all you have to learn now. Understood? Only 3 methods you have to learn. In that you have already learned 2. Yes or no? because you are very genius. As next and next, both you will finish learning. Yes or no? So fast. Great. So one more method you have to learn now. Remove. I'll show you that. Okay. So are you following now? For that, to understand that method, I'll give you an example. As next you understood. What does as next do? See here very clearly tells. Returns true if the iteration has more elements. What does next method do? Returns the next element in the iteration. More information you want, click. It will give you more information. Understood? Like this, you go on learning Java. Understood? So I can only set the path for learning Java. I cannot come sit beside you, code. So means this is the output, this is the output. I can't do all that. What we can do maximum is guide you how to use the library. Understood? Yes. See this now. So now I show you how to remove the, use the remove method. Now I'll ask you to write on logic. See in this interface, I show you, means the concept is remove now, but I'll give you a task. Okay. And think how will you do now. But I show you with library how easy it becomes. So I want to remove all the B elements in this collection now. My requirement is that I want to remove only B. Understood? So how will you do now? Means if you imagine using for loop now. Imagine you have to see if iterator was not there, you have to use what? For loop. Lot of logic you have to write. Anyway, it's complicated. Try it. Okay, you'll understand the complication. But I'll show you the simple approach. This is accessing now. And this is for loop, this is iterator. Okay, see this logic. Yes, see this. All I'll do is, I got the element, I'll check here. S dot equals of B, which method I'm calling now? Remove. I'm calling the remove method in iterator. So you are at a particular index now. Okay, see how it goes. Just concentrate on this logic now. Which logic? Understood? See till here it will come. Visiting it will come. Now you will check whether it is B. Yes. The cursor is at which index? Means it is at the index which contains B value. All I'll tell is what? Itr dot remove. Who is deleting the element now? Iterator. Cursor is deleting now. So it will delete B here. So with the for loop and all, it's more complicated writing logic. Understood? So that's why we prefer to use iterator over for loop when visiting the elements. There are more advantages. So it will remove this B. Again it continues. One more B is there. That also will be deleted. The cursor goes on deleting the values. You are not directly deleting in which one? I am not using list dot. Am I using list dot? How am I deleting? Am I saying list dot remove? No, I am saying iterator dot remove. Getting it now? So that's the benefit of using iterator. Anyway, that's one method now. See, after deleting, see now very tricky. You should be very careful with working. Anyway, it will delete all the elements and it will reach to the end. Once the cursor reaches the end of the array list now, finished, you can't use it again. You have to bring it back to the first position and use it. Because it is moved now. See here it will move. Next, if you want to print the elements, again what I am doing? I am calling the method list.iterator. Return type is what? Iterator. Means I am using the same variable. Right now it has moved here. Or you can use another one. Iterator, itr3. itr2 is already in the end. Understood? Or if you want, you can use another variable, or you can use same variable. So but now when you say itr, so where is the iterator now? Here the cursor. When you call that method, again the cursor will come back where? To the first. You should be very careful while iterating. Understood? Once you reach to the end, now it is gone to the end. You can't get, has next will tell what now? False. How will you get the element? So again bring it to the first. But how do you bring it to the first? Again call the method, which one? List.iterator. Return type would be what? Iterator. But I am using the same variable, which one? That's it. So see, I am iterating that array list twice. One for removing B, another for accessing and printing. That's it. Understood? We'll access every element, check whether it is B, yes or no. My question is now, what was our requirement? Remove all the B elements. So to remove all the B elements, you have to visit one by one and check whether B is there or not. Understood? If it is B, then you want to delete. So okay, it will do. The iterator will do it by taking the cursor now, and it will be at the last. So once it is in the last, you can't visit and print now. But I want to print, or I want to access. So that is why I am bringing it back to the first position by telling iterator dot next. Clear? So again it will come now. So again I will say has next, and it goes on printing. So in the second iteration, B values will not be present now. So concentrate on these two methods now. I have commented rest all output. Just focus on this now. See, contents of array list before removing. It'll okay. So these are the elements. B is there. Okay, but after in the second iteration, B will not be found. Clear? Any questions? Okay. So that's how you work with this iterator now. Any questions here? No. Yes, no. Library. Don't forget. Okay. We'll go with list iterator now. Now we'll see the difference between iterator and list iterator. So what's the drawback of iterator? What's the drawback? It moves only in forward direction. I want to move front and back. So what do you do now? Use a list iterator. Clear? So I'll show you how to use list iterator now. Same program, which one? Array list. See, I called which method now? List iterator. Now this method is not present in collection interface. It is present in array list. A list or array list. Understood? So that is why I say list iterator can be used with only classes implementing list. Understood? So we'll see more why. But first learn to use it. List iterator can move what? Same, and there's no difference. You open the document. Document gives you all the answer. See, list iterator is a sub interface of iterator. That's how they are related. Means it will have the same methods plus what? Extra methods. See, at the list iterator is extending what? Iterator. So same methods plus extra methods. What are the extra methods? To move front and back, both. So some extra methods are there. See, these many methods now. Add, has next, has previous, next. Some methods you already know. 3 methods you already know now. Which one? Has next, next, and remove. Some more methods I'll cover now. That's it. So Java is all about learning library, man. That's it. Okay. So then these are the methods. So we'll see now. First I'll show you moving front and back. So apart from moving front and back, it can do, see, list iterator is able to only remove an element. But list iterator is able to do what you know? Add also, update also, delete also. It can remove. Plus at the same time, say remove method. Yeah. Set means what it will do? Replaces. Add means what it will do? Adds an element. So it can do 2 more extra operations. Say add is here on the top. So you have to study now. Concept is there. While iterating, I want to add an element or do something. Fine. Support is there in the library. First, you should know what you want to do. Then you'll get the support from the library. Like this, and learn like this. Okay. Yes, we'll come back now. And very simple now. Already I have explained you. See here. List dot has next. What will it do? It will move front. I am not doing anything. Next, what I am doing? After when we are in the last, now I will call has previous. Now it will move back. Don't do ulta palta, it will not work. Understood? Means don't call first has previous, because cursor at the beginning. See here. When I call this method list dot iterator, where is your iterator now? In this position before first element. If you say has previous, where it will go now? This side. So I should say what? Has next, so that it moves in the forward direction. So you should know how to move now. Depending on your cursor position, you will move front and back. If you are in the first, there is no point in going back. Understood? If you are in the first, you have to move front only. If you are in the last, you have to move back. That's how you have to understand. So yes, has next. So it will move. It will print all the elements. But understand the concept. Here I am accessing by moving in the forward direction. Same, I didn't do anything. What am I calling now? Which method? So once it moves, like this it moves now. It goes on moving. So the list iterator will access all the elements one by one prints it and moves. And then when I say has previous, starts moving in the reverse direction. This is has previous. And what is the method? Has previous. Next method is what? Previous. Previous will get you the element. Same like next. Has previous will check whether the element is present or not. Previous will return you the element. Same. So two more extra methods. Getting it now? So we'll move front and back and see the output now. I've commented everything. Just see this. Yes. First time it prints what? Can you see it? C, A, E, B, D, F. Second, backwards what it is printing? F, D, B, E, A, C. So in forward direction it is printing as same C, A, E, B, D, F. Anyway, B will be there now because it's a new another program. Okay, B will be there. So it prints that. Next part, reverse direction. So you can move front and back. That's the advantage of list iterator. Understood? So you should know now when to use. If you use for loop, you lose these features. You can't in the for loop you cannot move front and back now. Understood? So, but with the iterator you can move list iterator. You can move front and back. Apart from that, more operations you can do. What is that? Adding and all that. That I'll show you now. Okay, this is done. So I'll modify the elements now. Same thing now. See, I just wherever for every element I want to append X. If it is C, I want to make it as CX. A means AX, something like that. That's updating now. Changing a value. You are not deleting the value. You are changing value. That's updating. Understood? Yes. So what I'll do? I'll get that. Then I'll say S1 plus X. I'll get the element. See, has next. I got the list iterator. Has next. Next. I got the element. I typecasted it to string. I did the appending. Then what did I do? List iterator dot set. In that index, in whatever index it is sitting now, first it is sitting at which index? 0th index. In 0th index, it will set this new value. Means replaces that value. Understood? It is replacing. Don't think it's going and appending there only. A new value is getting set here. So means set. What is the value of S2? CX. See, I got the value. It is S1. Okay. So what is the value of S1? C. Plus X. It becomes what? CX. So the value of S2 is what now? CX. So that time setting now. Using what? List iterator. So now it overwrites. Don't think it is getting appended here. Understood? It is updating. Means changing the value. Changing the value in the existing location. Next again. Has next. Cursor moves. Okay. Gets the value. What is the next value? A. So once it gets A, then what happens? I'll get the value S1 plus X, AX. That new value AX, I'll say set. So again it becomes AX, EX, EX, DX like this. Okay, so you can update it. Done? So now see, while now it will modify and move front, but to print the values, what I'm doing? I'm using has previous. So it will print in the reverse order. Which order it will print? Fx, Bx, it will print in the reverse order. Because for printing, no, otherwise you have to again come from the beginning and print. That's your wish now. How you want to print your wish? Okay, because after modifying, it went to the last. Okay, so once it is in the last, again what I'll do? From there only I'll start printing. Otherwise you can say has next, bring it to the first and start printing from the beginning. That's your wish now. But I'm showing you, my intention of showing you backwards is I want to show you the has previous method. Understood? My intention is showing has previous method. So it's only one print there. Fx, dx, like that it goes on printing. It's printing in the reverse order. Has previous, previous it goes on printing. Done? Any questions? Okay. Then next. That iteration is okay. Here comes the real iteration, which is very important from industry point of view. Remember this. Okay, this is very important. Those iteration and all very easy. This is also easy only. But here, interesting iteration. We are having what? Employees. And these employees have been added into what? Array list. So this is where you start using getter methods. SOP list means yesterday what it was doing? Simply printing all the values. Understood? So you know your user defined data, no? You know your user defined data? What is your user defined data? Employee. What is employee having? ID, name, phone, email. So then it is having segregator methods. Fine. So what I'll do, I'll create an object of employee. How many employees? Employee 1, employee 2, employee 3, employee 4. 4 employees are there. All this I'll put it into what? List. So if you want diagrammatically, I'll represent it. See here. What is the first employee value? E1 is having what values? This is E1. Address might be, some address it will have 101 or something. Or I'll take it as some address value, I'll take it as what? What address I'll take? Okay, it started with 500. Some address reference. Okay, means when you create an object, it will have a reference value, no? That is 500. Now, ID, name, email, phone. So what is this ID? 101. Sorry, the first 103. Name is Amog. Email is amog@ something. Phone is 111. So this is one object. This is employee one object. Then I'll create what? One more object. What is the value? 101. Name is what? Ravi. He'll have email. He will have phone. What is his phone number? 111. So this is employee 2. Address will be 501. Understood? So then next. What is the next? ID, name, email, phone. It will be 102. Name is Vinay. Like this it continues. So this is employee 3. Address will be, means it will not be continuous. Understood? Some addresses I'll take 500, 600, 650, some addresses. Okay. Some different, see they are all different objects. So then again you have ID. ID is what now? Last 102. Name is Kumar. So totally you are having how many values here? 16 values. This is E4. Something like address like 800. Some addresses are there. So these what I'll do after creating these objects. So okay, I'll add it into array list. You can see this now I'm adding employee 1, employee 2, employee 3, employee 4. I'll add now. So now add it. See this is your array list now. I've drawn it big. Okay. This is your list. This is your 0th index, first index, second index, third index. When I say list dot add of employee 1, what is getting added? The reference value. Understood? So it will be stored here 500 means it will refer to this. Then I'll add second one E2, E3, E4. So now I'll use the iterator. Understood? See if I print SOP E1, what will it do? It will print all the values. 16 values it is printing in one chart. I don't want to print it. My intention is what? To access the values for processing now. Getting it now? So how will I do now? So here you get the iterator. How will you get? List dot iterator. Return type is iterator. I use iterator. You can, if you want, you can use list iterator also, front and back. Okay. So I'll say now while itr dot has next. So next itr dot next. Return type is, yes, you tell me what is the return type? Object. So you will typecast it to what now? Huh? This is common sense. You can't get doubts here. You're not supposed to get doubts. What is the element there now? Employee. Typecast it to employee. You're telling string. This is what your stupidity. When you don't work in basics, this is where the problems come out now. And you'll tell doubt. What doubt here? It's pure common sense now. Use. Typecast it to what? Employee. I will use another name here. Oh, okay. So employee. You are getting the first object. It's of type employee. Now, SOP E dot get ID, because it's private method. It's a private property. Then what? SOP E dot get name. Call the getter methods. I'm printing, but actually you'll be using it. Get name, get email, call the methods. One by one you're getting the value now. So you'll get the elements of first employee. Iterates, you'll get the values of second employee. You'll iterate, you'll get the values of, means every employee. 16 records. How precisely you're getting check. Accurately you're getting one after the other. Or if you're interested, you can go directly with what? List dot get of 3. You'll get the employee of third index. List dot get of 2. See, organizing data is one story. Next, accessing the data is another story. Understood now? This is how you have to do it. And this is the most important subject in what? Iteration. Don't think it is difficult and I leave it. This is only what you are going to do in industry. See, throughout your life you will do this only. And you don't have to worry, it will become very easy. Every day if you do the same work, what will happen? Correct? It will become easy only. Understood? Means if you do the same work every day, it will be easy only. So you don't have to worry. These are all very simple things. And you will understand very clearly in projects now. So we retrieve the values from our database, put it into user-defined data like this. User-defined data will put it into collections, and then we'll start moving from wherever we want to any location. Understood? This is practically what you'll be doing. Understood? So learn collections from practical point of view, not theoretical. You learned too much of theory. I know you know what is ArrayList. You didn't come here for learning what? ArrayList AL is equal to new ArrayList A dot B. You didn't come here for learning that. You come here for learning what? True concepts, how they are going to be used in industry. Then learn. If you are really interested in learning, learn. This is what is the subject. Understood? So learn like this. Other institutes will teach you what? A, B, C, D, add, iterate, finish it. But this is the subject. Clear? So yes, that's what I'm showing you now. Shall I clear this? See, SOP, here I show you. See here. You see, if I print SOP employee list, what will happen? But are you accessing the values there? It will print. Why? Because toString is overridden, it is printing. But you are not actually accessing the value. Yes or no? If I comment toString, what will happen? To print the address. You will notice that yesterday. So it's printing. Actually, I am not accessing because toString is overridden. It is printing. If I comment in my employee TO, toString I will comment now. Where are the values? Show me. Where? So you'll have to, storing is one subject, using it as another subject. See this, only addresses. How you get the values now? Now you have to use the iterator. Clear? So it is commented now. What? toString is commented. Now see how I will get the value. Simple. So remember that when you are iterating the elements in an array list, no, be careful before you are typecast. You should know of type what it is. If it is of type string, typecast it to string. If it is of type integer, typecast it to integer. If it is of type employee, typecast it to employee. That is the crucial thing here. So you should be very careful in iteration because you'll be typecasting. Now why do you typecast? Because I want with object D, can I call this getter methods? It's of superclass. So I have to do typecasting. Why? To access the subclass. I have to do. But be careful while typecasting. This is what is very important in iteration, nothing else. As next you know, everything is easy. But be careful while you typecast. You should know the accurate type and typecast. Till now all I was using was string. This time I am using employee. Clear? So that's it. So very easy subject, man. See how you are doing. What Java flexibility. And problem is you never knew these concepts. That is your drawback. You never in your lifetime knew these concepts. That is why you are finding what? Some hiccup here in learning. Don't blame Java. Blame what? You don't have knowledge in concepts. Following now? Excellently it is giving support for everything. Excellently. You have a problem, take this solution, it says. Are you clear with this now? Iteration. You know how it works? First, has next, gets the first element, and you are calling what? Getter methods. Then has next. Second element it will get. Then it will call what? Getter methods. Next, has next, next. It will call getter. If you don't want to call, don't call. You will not get the value. That's it. It's up to you whether you want to call what? Which getter method. Understood? Are you clear? Fine. Any questions here? This is very important. If you have any questions here, ask. This is purely basics of core Java. How you design the class? Yes or no? Designing employee is what? Java no. This is user defined data. You should know how to design it. Then comes what? Java's library. I created an object of that, filled the values into it, accessed it. What big thing here? Nothing. Clear? Sit and analyze. Then you do it. So always refer the examples. Don't execute my program. Refer it, but code. Should use my examples not for running. You'll get the output. Okay, but use it for reference. That is why I'm giving you examples, not for importing and saying run output. You'll get. Will I give you any non-executable programs? Definitely, no institute will give you, nobody will give you. All executable programs only will give you, but you have to learn the concept now. So cluster purely teaches concept. Clear, be clear from now. Okay, cluster is going to purely teach you concepts, not output. Whereas the other institutes teach you what? Output, but not concept. There's a huge difference between our training and other institutes. Okay, they teach only output, but not concept. We teach what? Concept. Output who will get? You will get. Understood? So concepts are very important so that you can start getting the output now. Clear? Okay, next. This is done. Yes. Now very important iteration. Till now I was telling you what? Should be careful in what? Iterating. Yes or no? Yes, here. You should be very careful in iteration because when you are having dissimilar data, till now you are having all similar data. Your next question is obviously what if I have dissimilar data? Answer is there. What? Example. So concepts, you get your problems. I'll give the solutions through examples. So you added. I'll get the iterator. Yes, I'm iterating. Typecast it to what? Object. That is fine. But can I directly, sorry, here, yeah. Iterator.next is object only, no need of typecasting here. Yes. So then next, how will you typecast now? Blindly you can't typecast because see the first element is of what? Look, the first element is of all are integer only, but means numerical values. But one is in the form of string, other is the form of integer, other is the form of double. Different data now. Okay. In one class you have got one method now. Yes or no? So you should be careful in typecasting. How will you do now? Check using instance of operator. If it is an instance of string, then you typecast to string. Then use it. If it is an instance of integer, then typecast to integer. If it is an instance of double, typecast it to double and use it. So I will go on writing conditions like this. If, else if, else if, else if, more elements, more types you add. That's simple. An instance of keyword, I have covered it in what? Core Java. All basics of core Java only. Yes or no? Yeah? So you can visit. Okay, by chance, if I don't write if instance of string, let's see what happens. Sorry. I'll remove integer. Yes. So there are one string, one integer, one double. Means you are not casting it properly now. Understood? Means directly you should not see. One second. What I'll do is, one second. First I'll show you the output, then I'll do the R&D. Yes, you're getting the output now. Okay. What if I blindly typecast? You might have a question. In fact, all this you should do, but I'll do it for you. See, there's nothing now. I'll typecast it to what? String. and I'll try to call some method. Their typecasting only fails, huh? Anyway, simply I'll print. First one will execute, but the second one causes an class cast exception. How can you cast? So you'll get this problem. This is the most important thing to understand, and we'll see how this problem has been resolved in Java 1.5. So get this point very clear. Understood? I'm emphasizing means it's going to be next subject. Understood? So anyway, just understand this much now. You can't blindly typecast. You have to always check and typecast. Understood? Yes, sir. See, what collections knowledge I'm giving you, it is equal to 5 years of experience. People working in industry now, with 5 years of experience, they have this much of knowledge. Okay, if you have to learn in cluster, come for knowledge. If you have knowledge, automatically you'll get job. But ulta you are, without knowledge you want job. Clear? Fine. So anyway, just you do it like this now. Yeah, this is the actual way to do methodology. If it is dissimilar, understood? Fine. Now very interesting iteration. See, there is one list 1, another list 2, another list. How many array lists are there? 3. All these 3 where I am adding? In another array list. Possible. What brilliant man. Tell now how you are organizing data. Imagine. Okay, you are putting 3 array list into 1 array list. Why I can add now? Because in add method, what is that you have to pass? Object of anything. How will you iterate? You need double iterator now, because first iterator will give you what? Array list. Second iterator will give you the element. Diagram you want? Without diagram, where you will understand? Yes, what is the first list having now? 101, 102, 103. So this is list 1 now. One object. 100, 101, 102, 103, 104. These values. Now list 2 is there. $200, 201, 202, 203, 204. A third list is there. Getting it now? See, in fraction of seconds you should start understanding concept now. Once you start dealing with data structures. Clear? 3 lists are there. What did I do? After creating the 3 lists. Sorry, list 2 I have to print. And third list is what I'll do? This list I'm putting into what? One more list I have created, object. Which list? Array list only. Okay. If you want, you could have put it in what? Tree structure also. Imagine how you are organizing data. Support. See here list. This is another object. What did I do? The address of this is stored here. The reference of this is stored here. Some address it will have. 500, 600, 800. Some references they will have. Understood? It is stored. So it will have now. So now when I iterate, the iterator, where is it pointing now? This is list object. Okay. So when I get the iterator, list dot iterator, I'll get the iterator is pointing to what? Before first element. It is pointing here. This is the iterator. So has next. Yes, there is an element. Okay. So it will enter. So when I get it, itr dot next, it's of type what? Object. But it's of type what actually? Array list. Understood? You put array list in array list. So then, okay. So after typecasting it to array list, for this array list I'll get one more iterator now. Here inside the loop, for this array list I'm getting one more iterator. Has next. Next, it will finish all this. So elements are completed. Then what? This will complete. Then it means this iteration will complete. It will print this. Means next iteration will continue. What is the next element? Again one more array list. So you'll get one more iterator for what? Getting it now? Second, there you'll iterate. Then again you'll get what? One more iterator. Like this, you get the iterators and visit it. Understood? Terrific subject, but see, down to earth. In one day you are seeing how you are traversing anywhere. Okay, fact is here I am putting all this into a list. If I want, I could have put all these 3 array lists into what? A linked list also. But I am focusing main on array list. If I had said in which one? Linked list, if I had added, what would have happened? All these 3 array lists would have been added here now, next. But iteration process is same now. Hardly any difference is there. So it will be storing this reference here. This will be showing the reference here, and the reference would be stored here. But imagine the support given to you by Java. Understood? From 3 array structures you are storing in what? Linked list structure. Can you do this in C? Can you store 3 array structures in linked list? Imagine how difficult it is. Terrific concepts, but bringing down to earth now. Understood? Terrific concepts. So this is how it happens. Are you clear with this concept now? This is the maximum. More than this you will not traverse. I have shown you all kinds of traversing. So I gave you many examples. See, I give you many examples. Okay, end of the day, the iteration with employee is very important. Or iteration with strings. I iterated now, simple iteration. That is very important. But I gave you the maximum information so that you, because this is what you should be very focused on. Because in companies you will be doing this only. So that is why I took this subject in depth. So that you should never get any doubts while iterating. Understood? So done, and you can see all the elements now. It will print. Done. See, this is first list, this is second list, this is third list. I am printing it independently. See, this is the output. First list, second list, third list. You got the output now? What is it printing? So after that, I put all the values into list and print list, only list, our list. How it prints here? You can see here how it is printing. See, this is the first array list, this is the second array list, this is the third array list. In bracket you can see, bracket within bracket, yes or no, means 3 array list. Then I am accessing the elements one by one and printing. 15 values, so neatly organized. So means how you want to organize your data, tell, Java will support it. You tell in what structure you want, how you want, it gives you built-in support. Clear? Fine. Yes. One more last example we'll see of converting. See how many methods you learned today now in collection? Interface, contains all, retains all, summary, I'm just telling you. Okay, some methods. Then iterator, ListIterator, 6 methods. Then in iterator and ListIterator you learned some more methods. So too many methods you learned. And more methods you know, the less you will bother about programming now. Because you can directly use it. Understood? So this is the flexibility what you get in Java. Okay, so don't burden yourself by hearting. Throughout your lifetime, you are by-hearted. From now at least, stop by-hearting and learn it learn it properly, learn it. Okay, don't by-heart. Yeah? Fine. So next, one more last example, we'll finish it off. I show you how to convert an array list to array. I told you, long back, means in the first, we had seen what? In the introduction of Java, I told you one point. What I told you? All collections can be converted to what? Arrays. You can convert a linked list also to an array. Converting means primitive array. Very simple. See here, one example you see, automatically you'll understand. And here that example has been kept in on package com.cluster.ArrayList to array. In the first example, 2A array list examples, I kept it here. Just check out. Simple program. All you'll do is what? That's it, over. Tell man, what is your problem, you tell. But it's an array of type what? Object. Understood? It's an array of type object. Understood? So once it's an array of object, you know how to visit it. Object is a superclass. So let it be any element, because we don't know what elements are there. You understanding now why they are returning an array of object? Because we don't know what type of an element is there inside that array list. So that's why it will be of type object. So I visit now, but how will you visit in an array? No iterator, no list iterator. Use what? For loop. And I have extensively shown you how to work on arrays, primitive arrays. Okay, I have shown you arrays with primitive data also. I have shown you arrays with user defined data also. Both I have shown you. Understood? So this is how you can convert. So you can convert an array list into an array. Now what is the benefit of doing this? See, assuming that there's an old class, legacy means it's a class which was released in 1.0, Java 1.0 version. Some class I'll tell, like example class hello, means Java's class, not my class. Okay, so there they have written a method called as m1 and it says I'll accept an argument of type string array or object array. It says I'll accept an argument of type what? Object array. This is some class written by Java, think like that. So what will happen now? Can I pass array list to this? You can't. So obviously we forced to do what? Convert array list to array and send. Normal array. Clear? This is one reason. But we don't do this, but this is one very famous interview question. How to convert array list to an array? To array method. And this to array method is present where you know? Collection interface. Means even linked list also can be converted to what? Array. Tree set can be converted to what? Array. Anything. So from that structure, it will bring it into your, it will be copied into a new array. If you want diagram, very simple. What will happen? So this is array list. An object has been created. Okay, so what are the values? 1, 2, 3, 4. Some values are there. After adding some values, what will I do? This is list. Index starts from 0. Understood? When I say to array, is an array of object. Means remember they are of type object. All are stored in the form of what? Object. So here you'll have objects only. Object 1, object 2, object 3 you'll have. Means it will be stored like object only. Okay. Or you can take the same value only. Same value but it will be in the form of what? Object. But this is an array. Look, normal array. Array of object. So it will be referring now. Object A I have taken. Okay. This is an array. So I will visit now first element. But to visit the first element, what did I use? For loop. Because you cannot visit the elements using iterator in array. Iterator, list iterator is supported only for what? Collections. Understood? So that's where it stands now. Clear? So this is maximum what you iterate. Visit the elements. Clear? Okay. So I'll just print it for you. It will access now by using for loop. But typecast again. You should be careful now when you are typecasting. Because I know the elements are of type integer. I am typecasting it to integer. If you are having doubt, use instance of. Int value is 1, int value is 2. It's printing all the values. That's it. Done? So any collection can be converted to array. Why do you do it? One reason. If you want to send your collection to a legacy method, that is one reason. And one more reason is, see for some operations, like example, in linked list, you have stored your values in linked list. Okay. But example, now you want to do more of read operation. But reading an operation in a linked list is what? Bit? It will take time because I'll tell you right because I have not explained you linked list. So their read operation is slow in linked list. So that is when what you can do, convert linked list to array. For certain operations, array is found to be better than other data structures. So I'll convert the linked list to array like this. Or one more way you can do, how do you convert the linked list to array? Array list only you can convert. No, it depends on your requirement now. What will I do? A linked list, LL is equal to new linked list. Understood? How will you convert it into array? To array is one approach, but you will get primitive array. Fine. Return type is what? Array of object. One more is there. Array list, AL is equal to new array list. Yes. Pass that collection in the constructor directly. Document. Don't look at me. Document. Where is array list? Yeah. Can you see this constructor? You should know, no, I'm using the constructor, nothing else. Core Java, no? You know core Java very well. That's all. In the constructor, I'm passing the object of any collection. So there are many ways how you can do. Means you can pass any collection here, not only linked list. You can pass what? I see there are some elements in array list. I want to store all the values into what? A linked list. Add all is different. It will copy all the elements plus extra elements will be, means there that scenario is different. Here what's happening? They are transferring all the values from one type of a data structure to other type of a data structure. That's it. So flexible it is. So clear with all the three constructors of array list? You do it. That's your assignment. Understood? So that will complete now. So now you can see how many methods you have completed. Go and check. Maximum you have completed. Understood? And even in which one? Collection interface also maximum. So almost all you have completed everything in what? Array list. Only one thing is last pending. What? Sorting. If you finish sorting, done with array list. Understood? That's all last topic. And if you know this much concept now, iteration in tree set will be easy. Iteration in linked list will be easy. Any structure you take, adding elements will be easy. Sorting will be easy there also. That's it. One structure you struggle. The same concept will be applied there, but structures will be different. That's how it happens. Done? Yes. And now, yeah, some notes we'll see. So first we'll see the difference between what? Iterator and list iterator. Okay. So using iterator you can visit the elements of a collection only in the forward direction. There you can move what? Both forward and backward direction. We can remove elements, that's all, using what? Iterator. But you can add, remove and replace the elements. Here, it is available to all the classes. Which one? Iterator. Means with tree set and all you can use it. But list iterator cannot be used with what? Tree set and all that. We'll be seeing it. But just understand it is available to all the classes in collection framework. It is available only to classes which implement list interface. You'll understand it because you are not seeing classes which are not implementing other than list interface. That time you'll understand it. Then some more differences. Yeah, then next, one second. Similarity between both. Both can move in forward direction. Both allow removing elements. Now these are your interview questions. Whatever I did yesterday, today, they are all your interview questions. Up to 4 years they'll ask you. You go to an interview with 4 years of experience, these questions will come out, but in a tricky way. How will you do this? How will you do that? How will you do this? How will you do that? Clear? Done. Then some more differences. Difference between what? Yes, we'll discuss today. Difference between what? Array and array list. Simple differences. Arrays are fixed in length. Yes, a primitive array, fixed in length. Okay. Array list is, and once an array is created with some size, you can't alter the size. Here, array list is expandable. It can increase and decrease dynamically. Array can store both primitive and objects. Yes or no? Crucial point. If you want to store primitives, only array. See this. Int A is an array of what? New int of 5. String array is equal to new string of 10. So S is an array of type string, A is an array of type int. So A can store only integer values, S can store what? String objects. So your array can store both primitive data and objects, but array list can store only objects. Definite interview question. Difference between what? Array and array list. Definite. Okay. So array cannot store dissimilar data. But there is one catch here. If I make an array of type object, I can store any elements. I can add string also, I can add box also, I can add integer also. You know array of object now? What it means? Object E is equal to new object of 5. E of 0 is equal to new integer. E of 1 is equal to new box. Yes or no? E of 2 is equal to new string of hello. See that? Getting it now? If your array is of type object, you can store dissimilar data. Understood? But generally in interview you have to tell like this only what? Array can store only similar data, array list can store dissimilar data. Why ArrayList can store dissimilar data? Everything is stored in the superclass form of object. Understood? So these differences you should be very clear in spelling out. Clear? Okay. Then next, the next difference is there. We can only add elements in an array. Yes or no? In a primitive array, what can you do? Only add. I've got an array now. See, this is an array of int. 100, 101, 102, 103, 104. Apart from adding, what you can do here? Can I remove it? I cannot remove. Can I add in between it a specified index? No. So that's the meaning. We can only add elements into an array. That's it. If you try to add, it will overwrite. Okay, means after adding, if you try to add again, it will overwrite. We can add and remove elements in array list. We have to use for loop to visit the elements in an array. We can use iterator and ListIterator to visit every element in an array list. We cannot insert an element into a specified index, but in an array list you can insert. So this is the major difference between array and array list. Even though both support array structure, these are the differences. Understood? So you should know when to use which one. Next, when differences are there, similarity also will be there now. Now see the similarities. Both store values sequentially. Sequentially means what? One after the other. See, array structure stores values sequentially. Means one after the other. But it can be accessed randomly. Randomly means what? Out of 100, I can get the value from 40th index, 50th index. Randomly you can pick. Understood? Now both can access elements randomly. Then both allow duplicate values. Both can store multiple values. Yes. And insertion and deletion operation is bit slow in the array structure itself. Okay, it's bit slow in array structure. When you're adding and deleting an element, it's bit slow in that structure itself. So since both represent array structure, so that operation is slow in both the structures. Clear? Any questions? Okay, that's it for the day then.